Okay, we are back with our last major type of stoichiometry problem. So in this question, we are asked how many grams of ammonia, or NH3, can be produced when 206.9 grams of nitrogen reacts completely with hydrogen. So our first step will be to determine what's given and what's unknown, because that's going to help us identify what type of stoichiometry problem this is and how we go about solving it. So in terms of what is given, what's given to us, we know the mass of nitrogen, which is 206.9 grams. And what we're being asked for, or what's our first major unknown, is the mass of the ammonia. So because our starting value isn't a units of grams, it is a mass, and we're being asked for a mass, then we can identify this as a mass-to-mass stoichiometry problem. Alright, so now that we've determined what we have already and then what we're being asked for, our second step is going to be to write the balanced equation. So the question says how many grams of ammonia can be produced when nitrogen reacts completely with hydrogen. So we already know that the product is going to be ammonia. And then we're also told in the question when nitrogen reacts completely with hydrogen. So we know that those are going to be our reactants. We also know that they are both N2 and H2. Nitrogen and hydrogen, Hofbrinkel, they are both diatomic elements. So now we just have to go through and make sure that we balance our equation. And I'll just do that quickly because we've had plenty of practice with this. There's going to be 2 moles of ammonia produced and then 3 moles of hydrogen. So we've set up a molar ratio here with our balanced equation. To react completely, you'll need 1 mole of nitrogen, 3 moles of hydrogen, and they're going to react to produce 2 moles of ammonia. So our first step, since we're given a mass, we're first going to need to determine the moles of something that we know, because we cannot compare masses in stoichiometry. We have to compare moles, because masses tell you absolutely nothing about how many particles are in the reaction. So to determine the moles of nitrogen, we're just going to use our N equals mass over molar mass equation. So 206.9 grams divided by 28.013 grams per mole. And since the molar mass of one nitrogen atom on its own is about 14 grams per mole, if we have 2 of them, we know it's going to be 28. So then when you plug these numbers into your formula, you're going to see that around 7.39 moles of nitrogen are what we put into this reaction. Now we're going to go back to our balanced equation, and just like we've done before, we are going to create a multiplier that tells us the equivalent proportions of moles within this reaction equation. So if we want to know the mass of ammonia, we're going to have to set up a proportion that relates the amount of ammonia to the amount of nitrogen. So looking at the molar ratio of the balanced equation, meaning I look at the coefficients, I know that there are 2 moles of ammonia that get produced in the reaction per every 1 mole of nitrogen. That's going to be our multiplier there for our equivalent proportions. And I also know that we have 7.39 moles of nitrogen. So I can take that multiplier, multiply it by the amount of nitrogen that we have, and I know that I set up my expression here correctly because moles of nitrogen are going to cancel out. So when we multiply this equivalent proportion multiplier by the number of moles of nitrogen we have, we are going to get that 14.78, approximately 14.78 moles of ammonia are produced in this reaction. What's really good about this is that we have now determined the moles of ammonia. So we can use that information to then figure out what mass of ammonia has been produced, which is what we were asked for originally. So we have seen this rearrangement before, so we know that the mass of the ammonia is going to be equal to the moles of the ammonia times the molar mass of ammonia, which for us is going to be 14.78 moles times 17.03 grams per mole, just approximately. And then I know there that we're going to end up with a final unit in grams because the moles in our units, they cancel out. And then what we're left with as an approximate value, 251.71 grams of ammonia. And then we can just put a therefore statement to close it, to provide some sense of closure. Therefore, 251.71 grams of ammonia can be produced. So just to recap, what we first did was we determined our givens and our unknowns based on what was available in the question. We extracted that information, and from that we were able to determine that this was a mass-to-mass stoichiometry problem. Then we took what information we did have, which was the mass of nitrogen, and we converted it into a value of moles. Then from there, we set up an equivalent proportion multiplier to determine what amount of moles of ammonia would be produced based on the amount of moles of nitrogen we put into the reaction. We determined that here. And then once we had the moles of ammonia, it was a pretty quick job to then determine the mass. And we found a final mass there, which ended up being our final answer.